Hi guys, welcome back to Think Tank Online Learning. In this video, I want to find the volume bounded by the plane z equals to 9 and z equals to root squared, z equals to root 3, root x squared plus y squared, using three methods. Okay, so we're going to use three methods. The first method we're going to use, which is simple, is cylindrical coordinates. Then we're going to use spherical coordinates, and we're going to use the general formula to find the volume of this shape. Okay, so I'm given this shape. First of all, I think the first thing we have to do is to visualize this diagram. Okay, so what I'm going to do here, I know if we have a equation that looks like this, I'm going to say a squared is equals to b squared plus c squared. Automatically, this is a cone. Okay, this cone lies in the z-axis. Okay, so I'm going to visualize it. Okay, so this is the straight line for z-axis, then this one for x-axis, and this one for axis. Okay, so we have the plane z equals to 9. So I'm going to say this is the plane z equals to 9. Okay, so I am going to draw this cone. Okay, so this is the cone which you're going to draw. Okay, it's not that good, but at least you know. Okay, and this is the plane z equals to 9. Okay, so we're going to use cylindrical coordinates first. Okay, so in using cylindrical coordinates first, we need to know the shadow of this cone. As you can see, since the top part, this plane surface, okay, so since this plane surface is a circle, as you can see, this is a circle. Okay, so that means the shadow of this cone is a circle. Okay, but I want to find the limits. Okay, so the limits I want to find, first of all, I have to find the angle, which is theta, and I'm going to find r, the radius. Okay, so what happens if I solve this equation simultaneously? If I solve this equation simultaneously, okay, they intersect here and intersect here. So I'm going to get the coordinates of this point and coordinates of this point. So as you can see, this is going to be the diameter. By the way, I'm going to get the equation of this circle. Okay, so let's do that here. I'm going to say z1 equals to z2. Okay, 9 is equals to root 3 x squared plus y squared. Okay, and if we divide both sides by root 3 and square that answer, we're going to get 81 over 3 is equals to x squared plus y squared. Okay, and you know the equation of a circle is in the form r squared equals to x squared plus y squared. So that means if you say 81 divided by 3, we're going to get 27. So that means root 27 is equal to x squared plus y squared. Okay, if we say root 27 squared, we're going to get 27. Okay, now we have a circle that is radius of 27. So I'm going to draw that circle here. We're now in the xy plane. Okay, so this is the y plane, this is the x plane, and this is the z plane. Okay, so I'm going to draw the circle. The center is the origin, so here I have root 27 here, negative root 27 here. So this is the region I'm concerned about. What is my angle? Since this is a full circle, so that means theta will range from 0 to 2 pi. So this is theta will range from 0 to 2 pi. The radius from here to here, so r will range from 0 to root 27. But since we're finding the volume, we need triple integral. Okay, so what do we need? We're going to say 2 pi 0 for the angle, root 27 0 for the radius. What about for z? Okay, so this is the plane. As you can see, this is the top part of this cone, so automatically it's the upper limit. Okay, but if you don't know which one is the upper limit, which one is the lower limit of z, you can just plug in. Let's say if you plug in 1 here, we don't have any variable, so it's going to be 9. If you plug in 1 you're going to say 1 plus 1 root 2 times root 3, and automatically it's less than 9. So that means 9 is going to be my upper bound. Okay, 9, and my lower bound is going to be root 3 root x squared plus y squared. dz, this is for z, but dy dx, we're going to use the Jacobian r, then dr, d theta. Okay, and since we're using cylindrical coordinate, we can simplify here, because you know that x squared plus y squared is equals to r squared. Okay, so that means r is equals to the square root of this. So I can just say 2 pi 0 root 27 0 9 root 3 r dz r dr d theta. And now let's compute our triple integral. First of all, we don't have anything here, so that means we have 1. So I'm going to integrate with respect to z. Okay, and if we do that, we're going to get 2 pi 0 root 27 0, and here we have z. What about the limits? 9 root 3 r, we no longer have dz, so it's now r dr d theta. So we're going to say upper bound minus lower bound. Simple. 2 pi 0 root 27 0 is going to be 9 minus root 3. Okay, don't forget this r dr d theta. And now I'm going to integrate with respect to r, so I'm going to expand here. So this is 9r minus 3 root r. Okay, so I'm going to integrate after expanding. So I'm going to have 2 pi 0, 9 times r is r, and if I integrate 9r, I'm going to say 9r squared over 2 minus root 3. Here I have r times r squared, then I'm going to add 1 to the new power over 3. My bounds, my limits, 27 0. Then I'm now left with the d theta. Okay, and if we say upper limit minus lower limit, okay, here we have r squared, so that means 27 just going to have 9 times 27 over 2. Here we have r to the power 3. Okay, so we're going to say root 27 to the power 3, and that is 81. So we're going to get 2 pi 0, and if you plug in 0, we're going to get 0. So you're going to give 9 times 27 over 2 minus root 3 times 81 root 3 over 3 d theta. Okay, and if we simplify, you can see root 3 times root 3. Okay, this is going to cancel. Okay, and now I am integrating with respect to theta. So I'm going to just add theta to this constant. So I'm going to have 9 times 27 divided by 2. That is 243 over 2 theta minus 81 theta 2 pi 0. Okay, and if I say upper bound minus lower bound, what are we going to get? We're going to get 243 times 2 pi divided by 2, okay, minus 81 times 2 pi, and the answer is 81 pi. So that is the volume. You can just say unit cubed. Okay, and now we're moving to the next method. Okay, so now we're finding the volume using spherical coordinates. Okay, and using spherical coordinates in cone is very different from using spherical coordinates in spheres. Okay, so here our phi varies. Okay, that is the main difference. So what I'm going to say, I've decided to draw the cone here so that I won't run out of space. Okay, so what we're saying, I'm going to draw the triangle A or B. Okay, so this is O, this is A, this is B, and I've said this is rho. Okay, and we have phi. Okay, so this is phi. So as you can see, as phi goes to B, as phi approaches B, it's going to get bigger, but as phi approaches A, this is going to become very, very, very small. So that means phi varies. So what we're going to do, I know this is Z and this is the radius. Okay, so first of all, I'm going to express rho in terms of Z and phi, and we know that Z is equal to rho cos phi. Okay, so if we say this angle is phi, could say just say adjacent over hypotenuse. Okay, so that means phi is equal to Z over cos phi, and you know 1 over cos phi is equal to Z secant phi. So that is rho. And now we're moving to phi. So on phi, I'm going to express phi in terms of Z and R. So what I'm going to do, this is the opposite side, and this is the adjacent. So I'm going to use the definition of tangent. So I'm going to say the tangent of phi is equal to R over Z. Okay, unfortunately, we're not saying Z is equal to 9. So here, the same as saying 9 sec phi. Okay, but now we can't just substitute 9 here. What I'm going to do is, we know that R is the radius. So we've demonstrated that using the first method. R is the radius. And what is R? R is equal to x squared plus y squared. We know that x squared plus y squared, or under the square root. What about Z? Z, or given Z here, we can just take its root 3 x squared plus y squared. Okay, so as you can see, we're seeing that phi is going to be the tangent inverse of 1 over root 3, that is pi upon 6. Okay, normally you won't be given the value of phi and the value of rho, so that's why I've decided to show you how we can calculate the value of phi and the value of rho. And now, after doing that, we're going to set our triple integral. Okay, so our triple integral, okay, let me use red. I'm going to say V, or triple integral of V. And what is our Jacobian formula? Instead of writing dz dy dx, we're going to say rho squared sine phi d rho d theta d phi. Okay, and from the first example, we've seen that the top part is a circle. Okay, so the shadow is going to be circular. So that means theta, which is the angle, ranges from 0 to 2 pi. Okay, and we have phi here. This is rho, sorry. We have rho ranges from 0 to 9 sec phi. Okay, you can't just substitute saying rho is equal to saying rho equals to 9 sec phi, and you say sec pi upon 6. No, rho is going to vary. Okay, from here it's going to be the radius of the sphere, but as soon as we move from B to A, okay, so this is going to increase at the rate that is proportional to 9 sec phi. So that's why we're going to express rho in terms of phi. Okay, What about phi? Okay, phi is from 0 to pi upon 6. Okay, and now we're good. So what we're going to do is phi is going to be my outer integral, so I'm going to say pi upon 6 is 0, then 2 pi, which is the r, which is theta, from 0. Okay, and I'm going to say phi, my inner integral, rho, my inner integral, 9 secant phi 0 rho squared sine phi d rho d theta d phi. So now that means I'm integrating with respect to rho. What I'm going to do, I'm going to just add the power. So here I got pi upon 6 is 0, 2 pi is 0. So this is going to be rho to the power 3 over 3, my limits, 9 secant phi 0, and this 2 have sine phi. We've eliminated the rho, so this is the theta d phi, and then here we're going to just say upper bound minus lower bound. Okay, and if 0 is our lower bound, so this is going to be pi upon 6 for phi, 2 pi for theta. So we're going to have 9 to the power 3, and 9 to the power 3, that is equal to 243. So we have 243 here, sine phi d theta d phi. Okay, we're not going to integrate phi, still you have theta. So if you integrate with respect to theta, we don't have theta, so we're going to treat all these as constants, and we're going to get, okay, let me do it here. So it's pi upon 6 is 0. Okay, since 243 is a constant, I think it's safe to put it out here. And now I have theta, my limit is 2 pi 0 sine phi d phi. Okay, so as you can see, okay, I've made a mistake here. The limit for phi here was 9 sec theta, so that means if we say rho, so the limit for rho to the power 3, we're going to get 243 secant to the power 3 phi. Okay, that same applies here, so we're going to get secant to the power 3 phi. Okay, sorry for doing that, for forgetting. Okay, so now that means this is equal to upper bound minus lower bound. We have 243 here. Okay, pi upon 6, 243. The upper bound is 2 pi, the lower bound is 0, so it's 2 pi secant phi sine phi d phi. Okay, so it's d phi here. Okay, and now as you can see, we're going to integrate with respect to phi. Okay, so let me write here 243, the integral of pi upon 6 0. Okay, so you have 243 times 2, so I can say 2 pi times 243 secant phi sine phi phi. Okay, and now we need to use substitution, okay, in order to integrate here. Okay, so I'm going to use this identity. We know that secant is same as saying 1 over cos to the power 3 phi. So if we say cos to the power 3 phi times sine phi, okay, so I'm going to say sine over cos, we're going to get tan phi secant phi. Okay, so now if I have this inside an integral, what I'm going to do, I'm going to use substitution. So I'm going to let my u be equal to tan theta, tan phi, so that the moment I'm going to differentiate tan phi, I'm going to get secant phi, so that secant phi is going to cancel. So that means I have, okay, 243 times 2, that is 486 pi. 486 pi, and I have pi upon 6, 0 tan phi, this is tan phi secant squared phi d phi. Okay, so what I'm going to do, I said I'm going to say let u be equal to tan phi du d phi is going to be secant phi, and if I make d phi such with the formula, we're going to see that d phi is equal to du over secant squared phi. Okay, so if I come here, I have 486 pi. Okay, instead of having, let me just put my limits, pi upon 6 is 0, I'm going to say tan is now u 6 squared phi. Instead of writing d phi, I'm going to write du over 6 squared phi. And as you can see, 6 squared phi into 6 squared phi, we're going to get u, and if I integrate with respect to u, I'm going to get 486 pi u squared over 2, my limits, pi upon 6, 0. Okay, so this is what I'm going to get. Okay, unfortunately I'm running out of space, so what I'm going to say, what I'm going to do, u, we know u is tan phi, so u squared is tan, this is equal to 486 pi tan squared phi, okay, over 2, because we say u squared over 2, then our limits, pi upon 6, 0. So if we plug in our limits, tan squared pi upon 6 over 2 times this one, we're going to get the same answer we got when we use cylindrical coordinates, and that is v is equals to 81 pi. Okay, and now we're going to the last method, the easiest method. Okay, so this method is in case you're, let's say you're in a test and you're not sure. So we have our cone, this is a cone, okay, and you know z was 9, and we have our phi, say phi is pi upon 6, okay, and r, you've calculated r in the first place, and r was root 27, okay, so h, which is the height, that is 9, then pi is still pi. Okay, and you want to find the volume of this cone without using calculus. Okay, so volume equals to 1/3 pi r squared h, 1/3 pi r squared, that is 27, times height 9. Okay, and if say 9 times 27 divided by 3, you're going to get 81 pi. So that means we're correct. Okay, thank you for watching. I offer support in the form of likes, comment,